Imperva protects applications wherever they live and at the pace of development. From securing applications at runtime to protecting APIs in any cloud environment, only Imperva offers a unified solution across edge, application, and data to help you achieve more and save money. Start a free trial today and quickly protect your web applications at securityweekly.com/Imperva.
Welcome back to Application Security Weekly. We just talked about IE11, browsers, and bug bounty programs, and we didn't even mention how cool John's shirt is this week. I am your host, Mike Shima. I'm here with John Kinsella of the Cool Shirt, so all of you listeners out there, at least take a peek at the website. We'll make sure to throw up one of the splash pages of for the video. But it is just about time for the news. First, don't miss any of your favorite Security Weekly content. Visit securityweekly.com/subscribe to subscribe to any of our podcast feeds and have all new episodes downloaded right to your phone. You can also join our mailing list, the Discord server, to chat with us right now and follow us on social media and our streaming platforms. And you can join us June 29th for a webcast with Tyler Robinson and Bo Bullock to learn how to pivot into the world of crypto security, and they mean cryptocurrency. Visit securityweekly.com/webcast to register with only your name and email. Plus, don't forget to check out our library of on-demand webcasts and technical trainings at securityweekly.com/on-demand. All right, so during the break, hopefully you're working on your character, John, for Free RPG Day coming this Saturday. But in the meantime, I suppose we probably should cover a little bit of the news that's come up.
A few things. One of them that was actually a little bit older. I think this came out 2 weeks ago by now, but I wanted to save and have a chat with you about. This was a cool Hertzbleed attack. So the Hertzbleed attack, it gets it obviously gets kudos for a great name, a branded vuln. It's a great riff on Heartbleed, but it's pretty neat. And a couple things that stood out to me is one that they demonstrated a remote timing attack that was able to recover a key from a crypto algorithm. Now, I'm going to hand wave a few things. This is the algorithm, the implementation was Psych, which is a post-quantum key algorithm. Post-quantum algorithm, meaning that it's not as so easily factorable as something like RSA. So set that aside. That's less important. What was really neat is that they came up with a chosen ciphertext attack. So they said, these are some very particular types of ciphertext we want to submit remotely, over the network into this system. And what they saw is that the way the algorithm was operating, they could extract, or they could, based on the power and frequency consumption that the CPU was putting into the operations to perform the cryptographic algorithm, those were remotely discernible. The timing was coarse enough that after about 36 hours in one case and 89 hours for another library, they demonstrated being able to recover the key. Now, one more thing, and then perhaps I'll let you get a word in edgewise, Mr. Kinsella, is that the neat thing about this, it was also performed against a constant time implementation of the within the particular algorithm. And that stood out to me because constant time implementation of like a string comparison, a hash comparison. These are one of those generic recommendations like use prepared statements. That are common security aphorisms that are basically assumed secure or assumed to be very good advice. But in this case, it was pretty neat to see the researchers focusing on that constant time implementation and having a pretty novel attack to be able to demonstrate how to pull key information out of a server. So pretty neat. Doesn't look like it's going to be a scramble where everybody now has to go and change all of their TLS certs. All the CAs are scrambling because of this is pulling out information that remotely that attackers shouldn't be getting, but still nothing to sniff at. So that was me. That was me with my love letter to a well-named Heartzbleed attack. Hertzbleed, nothing to sniff at. I was going to say it really gets my clocks running. I know all the groans from our listeners. Sorry. First thing on there, what's the phrase? I even wrote it down. Post quantum.
That was one of my, thanks for the flashback for RSA. That's one of my sort of takeaways from RSA. That was one of the buzzwords I've seen get thrown around. So I'm doing a roundtable in a few weeks with some folks from CSA here in Seattle. What do we saw at RSA? And that's one of them. Ooh, post-quantum. So what I want to do quickly there to start this convo off is to go back and remind people the reason that constant time crypto algorithms are used is because previously we had attacks where folks were able to discern a crypto key or other secret by doing timing attacks and figuring out how long it would take to have that go through and you change your the plain text which you're trying to encrypt. You see the difference in time. You're able to figure out the key that's being used behind the scenes, right? So to fix that, to mitigate that, we went to constant time. And the reason I mentioned that is because one of the things I think about in my mind is, maybe we need some sort of mode in the CPU that, if we're doing crypto, that it sets your clock to a, set frequency. It doesn't do either turbo or power efficiency. It just sticks at like this standard speed for a certain length of time, and then you get something out of it. But the reason I'm mentioning those two together is, okay, well, in a few more years, now we've got constant time and constant frequency. What's the next one we've got in there? I guess power usage. Power usage is harder to detect remotely, but my guess is that's what people will start thinking about next. But I think it's neat to see people doing stuff like this. I didn't search. I don't see the word machine learning in here. And the reason I mentioned that is it seems like this would be the type of thing which ML is fairly useful, right? Just do a bunch of this, like you said, 36 hours, bring that data back and do some crunchy. The machine learning is pretty good at that particular type of crunchy. And the reason I mentioned that is I think that's one of, it's good that we have some of these ML tools out there. I'll foreshadow to another story and say, you could go to a cloud service that provides provides machine learning and data analysis tools, and bring that data in there and start looking to see when you find the vulnerability. It seems like this would be, fun to throw into Jupyter Hub that's, what I've been playing with most recently. But it's the attack itself is novel. I think people are going to be thinking about, why is this not a big deal if you can do it remotely? But it's still not quite as easy as it sounds. So I think it's going to be fun to see if we hear more about this, Mike, between now and the end of the year. That's only 6 short months away.
Indeed. And I didn't connect this to the Pac-Man vuln. That was another CPU Spectre class style of vulnerabilities within the new Apple M1s. But I mention that now just because there is definitely some ongoing research about just what's going on within that CPU. And I couldn't think of something good to riff on from constant time, constant frequency, constant power. But you've got some constant segues set up for Azure here. So we're going to shift into a different type of vulnerability now that, to me, one aspect of this just stood out as dead simple in the sense of a shell injection. But I know this is an area of Azure, and our friends over at Orca Security have written up another article about how they were basically bypassing tenant isolation within Azure. In the write-up here essentially showed, or a key aspect of it, showing that they got in through an ODBC connection, that rather than sending a link into the login URL field, they sent in piped commands, and game over once that happens. So there's one other aspect that stands out to me, but I'm going to keep our listeners in suspense while I throw over to you, John, and see why this one particular perhaps makes you happy to read about.
Make our poor listeners have to put up with listening to me for a few minutes before you get back to the good stuff. I see how it is. Where do I want to go with this? I think I'll be curious to hear now. You've got me even wondering, what you're foreshadowing. The timeline's interesting, just from the point of it took them 3 attempts to actually get this right, the patch right.
There you go.
Slight nitpick. My understanding is MSRC usually doesn't create the patches, but they work with the application teams and they create the patches and then they're applied, and they're sort of a little more project management with security expertise is the way I think of them. Don't mean that in a bad way. But I don't think, I'm guessing the MSRC didn't actually create the patches. Yeah, it's why does it take 3 going back and forths? That's sort of the point there, right? And sort of going back to my last comment in the previous segment about, you know, which team is getting which product is getting priority and how they're being engaged. I wonder if this is a little bit of that. Maybe like, you know, it's not SynLapse, it's Synapse. So it's a you know no one's using that not that many people are using that data analytics tool. We're not as concerned about that as I said before, Outlook.com. I don't know if it's a bit of that, or just they didn't understand, or Orca wasn't doing as good a job explaining as they did in this blog post, or why. That would be an interesting part to me about this. And it's not the first time we've seen it, right? There have been a few times over the last year or 2 or 3 where it's taken Redmond more than one attempt to get that patch right. I know these things are complex. And there's always sort of ways to wiggle, but that, you know, you'd think that if you have, I guess this again comes back once again to the last half discussion of bug bounties. So frequently when you submit a report, it goes radio silence until they're like either a thumbs up, thumbs down, we're going to fix it, or thanks, but you can, what were the words? You're free to blog about this in public and let us know if you do so we can see how it goes. I'm like, great. But the reason I mentioned that here is it seems like if you're running a bounty program, Mike, you would want to engage with that researcher and say, hey, we're thinking about this as a fix. Do you think this would mitigate what you're doing? And right, actually have a conversation there. And, you know, you've got someone who cares enough to put that report in. Wouldn't you? And I don't think this is specific to these guys. I think this is a pretty common thing with bug bounties in general, from what I've seen, is you throw something over the fence, they go thanks, and they go radio silence, and then you hear about, you know, we're going to release this next week and rah. So that should be a conversation, folks. Like, you know, if someone cares, reach back out to them and go, hey, thank you for this. What does this look like? We're addressing what you were talking about, or you want to give us a talk? We've put this on 1 or 2 machines. You want to give it a try and see if it actually mitigates it, or that should be a conversation there. So that part is interesting to me.
Yeah, and you definitely honed in on you took the wind out of my sails as you honed in on the very point that I wanted to make here about the difficulty that we've seen not, you know, commonly in many bug bounty issues about patching the patch, or, you know, the original researcher says, oh, this is how we bypass it. And it's always a question of why is that? And a little bit of it, you know, you're touching on, you know, some possibilities there. And we don't know specifically in this SynLapse case, but it could be, is it just communication? It's more of, here is the 2-line write-ups that say, look, I can use some command injection on the ODBC, on this ODBC packet. So go fix it. And then they say, oh, look, now here's another way I can re-encode it, and just kind of trickling out data rather than just having an upfront clear explanation. Another possibility, of course, is that these are complex systems, and it's often hard to figure out. A lot of these patches can't necessarily turn around an architecture change. They're doing patching, kind of patching an instance, or patching a couple different instances of these, unfortunately, the vulnerable, flawed patterns here. And especially within 90 days, that's possibly all that can be pushed out for large software applications. So there's lots of possible reasons why, but this goes back to perhaps repeating myself maybe one more time than I should be. But as you're awarded $60,000 for this particular bounty, I'd be really curious, especially to see bypass patch, patch the patch, bypass the patch, patch it again. What was the amount invested, both on Orca's side, for that matter, though maybe that doesn't matter quite as much, but Microsoft's just investment into fixing this? And that gets to the sense of, there's the cost of a bounty that is $60K, but there's also the cost of fixing. And just I'm basically just trying to put that idea of how much does it cost us to fix these flaws. as they come in through a bug bounty program or they come in through other types of tools. So that's the point I wanted to belabor there. And it does connect us to another bounty right up here that, if you look at the timeline, also had a 2-year timeline, which I just have to double check because that seems like such a long time, although it's in the firmware space. So here I'm talking about the title of it is called Hard-Coded Backdoor. But if you look through a couple of the vulnerabilities in this list, they're those dead simple types of C-based buffer overflows. And there was another one, just a hard-coded, Etsy password file, basically, and that you could. I'm running out of words here because it just looks like we've gone back in time to simple vulns, except this looks like it's a modern hardware stack, and 2 years from the initial contacting the company's product security incident response team to now releasing the advisory. So a lot of things that I'm just kind of racking my head about is, what are the lessons to learn here aside from just C is bad?
I can't remember. I saw something in the last few weeks. I might have even put in one of the previous show notes. I don't know if this one. It was a router. It might, anyways, let's just spit it out. There was another one in the last few weeks where the vendor was not going to. There was a known admin password, and they're like, "We're not removing that because that's used for troubleshooting." And I'm like, "What? That we know that, but you're not understanding at all." Yeah, I think it was someone else. That was like an IoT device of some type. But point there being, yeah, there's a lot of this type of thing. And I'm going to tie this back to the last, excuse me, story. Let's see, 2 things I want to bring up there. I'm remembering one. So the 90-day thing, which you mentioned, the sort of, I think of it as the Project Zero from Google, their sort of mandate that you must borrow. If I'm working with a vendor and they're making progress, and they're actively engaging, and they're they want to try and get something done, I'm going to be flexible. If it's a small vendor, I've been working with a small vendor on something since the beginning of the year. Actually, it might have even been December, and they're not getting it, but I'm not going and publishing and just I'm trying to get them to understand and help, and it's so I will frequently be a lot more flexible about that type of thing. And hopefully we'll talk about that in a future show. But if the vendor, which I think this is, where they're giving me radio silence and they're not trying to fix it and they're just hoping I go away, I'm more than happy to sort of, shine a brighter light on that. So this is a, I don't know who's heard of this vendor. Nexons? I'm sure they're selling stuff, so they're making money somewhere, and they've got a customer base. SA, I'm guessing that's got to be either Germany or Switzerland. So it might not be as many of our listeners. But anyways, the point being, they're probably a little more niche. So they're, I'm guessing again, a smaller company. Looks like they're running some open source software on there. Well, obviously. So they're probably just doing the minimum to try and survive. I'm just trying to talk through like how did they get in this place where they've got software on their hardware that they're not willing to quickly handle security issues on. And it's probably they've, I just saw a mention of SmartBearer, right? So it's, if you go in, you decide you want to sell a switch, you've bought some stuff probably from China, now you need an OS on it. Okay, well, let's go and get one of the distros and splat that on there so we can start selling this thing. What's the chance you've actually gone through and looked at all the software on there? And a networking OS is pretty small, but still, what's the chance you've gone through and looked at all the utilities, figured out what are they doing? Have you hardened it? Have you removed stuff you didn't need? Like that's a fairly small, simple project compared to our first segment of how do you secure either IE or Edge. But still, you have to have that team to do it, and I don't know. That's not justification, but I understand why this could take a significant period of time. .de or German, sorry. Anyways.
Yeah, and I think to me the thing that did stand out here was the amount of time, because I'm less well, I won't choose my words carefully. I'm less concerned. I'm less excited about the actual amount of vulns in here, and more interested just in what is the speed to resolve them. Because I'll be first to admit that vulns are going to exist, especially as you're pointing out, they're pulling in a lot of open source dependencies. And so, just at the very least, an SBOM might have helped here. So I'll throw that out there for anyone who has a bingo card going, just to say these are old. Update them. But if it takes you a long time, even just to do point updates for open source dependencies, that's just not a good sign of modern, call it DevOps practices or modern coding practices. Obviously, don't know all of the insights into here about what the extenuating circumstances could be, but it definitely just raises lots of questions to see that long of a timeline. And speaking of long timelines, I'm going to use that to pull in another interesting write-up from Matty Stone over at Google's Project Zero. Yes, I know I highlight these blog posts quite often, but this one I think is nice tie-in with our previous segment talking about IE11, just as well as that time dimension of vulnerability. So this was a deep dive by looking at a vulnerability that was announced back in, I want to say 2013, was identified, fixed, but then due to some refactoring, which is one of my favorite things to do within a software project, not necessarily the smartest amount of time investment, I'll be first to admit, but I still love doing them. It was apparently reintroduced a couple years later in December 2016, but that reintroduced vulnerability apparently wasn't identified until basically this year. So it was really interesting to look at that and to think of what does that imply versus in terms of security testing, both on just security tools, call them fuzzers, call them just code scanners, as well as just test cases being created to check, to say this was a security bug, we fixed it. Here's some test cases to check for regressions. But maybe those test cases just weren't robust enough. And we covered one that was a couple weeks ago that was, a 2-line fix in like 100 lines of test cases that I think even impressed you, John. So this is another case where just one of those interesting things to look at in the sense of have a postmortem. How did this happen? Why did this happen? Less so on the specific flaw itself, but more on the process and the practice of building software.
Yeah, and I think I said it then, and I'll say it again now, right? It's as developers, we're not just so much we're lazy, but we're frequently under the gun.
Yes.
I one of my patterns, which I'll do, is if I'm either not sleeping well or I'm a little sort of ditzy, my blonde comes out. I will realize that my code is probably not going to be as good as it should be, and I'll actually write more unit tests around that particular code. It's something I've been doing the last few months to try and minimize some of the bugs. But still, I'll find myself, if it's like, we're coming up near the end of a sprint, or I need to get something out to a customer or something like that, the number of unit tests I write are if I see it's going to take more time to actually set all the data structures up to test something properly, I'll find myself doing maybe some of the quicker unit tests. I'm like, it's tested, but it's maybe not tested quite as good as it can be. And it's probably the same thing here to a degree. There was a sentence I highlighted in her write-up. Attackers don't need novel bugs to effectively exploit users with ODAs, but instead can use vulnerabilities closely related to previously disclosed ones. And that's that concept of, back to sort of what you're talking about of a rewrite. And I think we've probably seen many times on this show where something which gets popped, it's not so much, an ODA doesn't have to be brand new research. It could be taking something which it's been seen before, but we're going to sort of change a few things around and make it work a little bit differently. And what was, as we were saying before with the Microsoft stuff, just because it's patched doesn't mean it's completely patched, or it's always patched. So that's unfortunately one of the tricky parts of this stuff is A, getting the patch done right, but B, also making sure that, if you do go and have someone like Mike in your company who goes and wants to, get everything reworked all the time, keep that dude in check and make sure you still test what the state of thing is when he's done with stuff.
Very, very fair point, John. I will try to salvage my reputation here by saying, also talking about bug bounties, is always looking for variants rather than just looking for the bug that was reported. Look for all of the instances of that similar pattern, and look for variants is, I think, what in the very second sentence of this write-up. And this is why a lot of the security industry is looking to tools like a semgrep, for example, or a CodeQL or something like that can say, where else is this flaw? And let's go and fix those areas as well so that we can fix all the adjacent vulnerabilities that the attackers are going for. And with that, I'm going to have to segue into something else so that I don't get picked on too much for my habit of refactoring. Speaking of time, there is just a quick article about Ruby, moving the package management ecosystem to MFA. The timeline there is nice. It's pretty aggressive, actually, going to try to get everyone onboarded or to mandate it by mid-August. That's a little bit different from GitHub, which admittedly has a much larger user base that was looking to require MFA for all of its users by the end of, I believe, 2023. So it's just kind of interesting to see what the timelines there are for adoption for what I think is just a non-controversial type of recommendation, but one that does have a couple hard edges to it in terms of account recovery being the new venue into account takeover rather than just guessing passwords. So not sure if there's anything you want to throw on top of that, or you want to talk about another article that you highlighted this week, John.
Quick aside, hopefully people will find it funny. Your mention of account takeover. There was a VC out there we were getting ready to talk to sometime in the last few weeks, and we knew he wasn't. It was someone who's never going to listen to the show, and he's not really receptive to security and all that type of thing. But as we get ready to talk to anybody, you do your research, and we saw this fine fellow was talking about in public, asking to know if any of his friends worked at Facebook because he had been locked out of his account. And he wanted to know how he got back into his Facebook account if he didn't have access to his email or phone number anymore. And it comes around bites you if you don't think about this stuff. The Ruby stuff itself, interesting. There were a few people, Mike, I think we even covered on this show, that did get offended that they had to turn on MFA and someone would actually dare make them do that to their projects. So some people care. I'll say it. I personally am fine with those people moving somewhere else and not, doing software. I should be keeping a little more open in mind. I'm not sure how to mix those two together. I'm happy to talk about that. But let's see. I think one of the last things I would like to leave people with, again, going back to the data science things, if it's I mentioned us using Jupyter. If folks out there are either developers or security people, or they've got a favorite way that they're doing data science with their projects, love to chat with you. Just sort of, share notes and think about how we do this type of stuff. So hit us up on Discord or Twitters or any of the usual places. But let's see, in the last minute or two, there was one more story I had in there, Mike. I don't think we covered before, but feel free to correct me. Microsoft and Intel released a joint warning about memory mapped I/O on Windows 10 and 11. Back to speaking about Windows. And this is, again, probably falls into that category as we were talking about, not quite the same as the time-based or the frequency-based attacks, but another sort of core part of the that application stack, to use a phrase, is that memory mapped I/O. And what they found in this particular case, and they've got 4 CVEs across this with fairly high criticality, I believe, is being able to use that concept of memory mapping to access data which is now stale, which had been used in a privileged process. So privileged process, rings through, you're going in and doing your specific sensitive work, whether that's just context switching or actually doing compute. And then when you're done, you think you free that memory, you think it's no longer being used by you, and you can keep going about your thing. And then some other process goes and somehow maps that memory and is able to read what's in there and see what was previously considered sensitive and protected. Where they're seeing this as a potential issue is in shared platforms like cloud providers. So, and the reason I mentioned this, I want to talk about it, again, no, we're running out of time, but the aspects, not so much of just the vulnerability itself or how do you mitigate it, or how do they patch it, But if you are going and writing for a shared platform, whether that be, I don't know what Azure calls them, so I'll say an EC2 instance or a virtual machine or a container or a Fargate container or ECS container or Kubernetes, or let's go further and say Lambda. If you're writing for one of those, any type of shared environment, how do you write your application in such a way, and there are answers to this, but to think about it, how do you write your application in a way that if someone else on that same CPU just gets context switched it over to them, that they can't go and map previously what was your memory and actually get some of the data out of it. So I think that's sort of interesting to think about for our listeners, excuse me. I'm thinking too much about users.
No, I think that's a great, great points, a great way to wrap up on there, John. So I'll just echo again, if you've got doing some data science, or if you have some additional dimensions you'd like to add to our discussion of bug bounty, please let us know, as well as just let us know what kind of articles that you're coming across you find interesting, or topics you'd love to hear us talk about. And so with that, it was time to wrap up. I want to say thank you once again to John Kinsella for joining us and chatting through both of the segments today. Thanks to everyone for joining us as well and listening. Please remember to subscribe, hit that like button, check out the show notes, and we will see you again next Monday back to our usual frequency on Application Security Weekly.